Overloading. What is overloading? Overloading simply happens when you give two or more methods the same name within the same class, and the method is then called overloaded method. We have already implemented overloaded methods before, but we didn't know that they were called overloaded methods. When did that happen? It happened when we defined multiple constructors within the same class. And we said that if you want to define multiple constructors within the same class, then make sure that these constructors have different parameters and different data types as well. Why? To make sure that the compiler can distinguish between these multiple definitions. Now, to ensure that overloading happens, you must ensure that the different method definitions have something different about their parameter lists, either by the number of input parameters or by their data types. If a method inside a class is defined multiple times with the same name, so how the compiler distinguishes between these multiple definitions? Java distinguishes between these definitions by number and types of parameters. So either by the number of parameters or by their data types. Sometimes when you try to call a method that is overloaded, you cannot find a matching definition for this method. So what the compiler does is it tries to attempt to do type conversions. And this happens if the data type can be converted to another data type. So if I have a parameter in a method defined as, for example, double, and when I call this method by supplying integer, then the compiler will not see the definition of a method that has integer input parameter. It will try to do conversion. So since there is a method that the input parameter is double, then it will convert this integer into double and will use this method instead. For any method you define in a class, the method's name and number and type of parameters is called its signature. Therefore, when you define a method multiple times with the same name in a class, make sure that each definition has different signature. To see how overloading is implemented in a program, let us take an example. In this example, we have four methods in the same class overload. The first one is the main method, and the others are in fact the same method because they have the same name, getAverage. The purpose of these methods, the three different definitions for the same method, is to find an average between numbers. The first method finds the average between two numbers. The second method finds the average between three numbers, and the third method finds the average between two characters. Notice that all of them have the same name, but the compiler distinguishes between them by the parameters. Here, the first definition has two double input parameters. The second definition has three input parameters, three double input parameters. And the third definition has two character parameters. So when we call one of these methods, the compiler tries to match the parameters to select the appropriate method. Let's go over the program. Now, in the first line in the main method, we are calling the static method getAverage, but which getAverage the compiler will call? Since the parameters we have for the invoking method, two double. So the compiler will try to search for getAverage that has two doubles, and it will find one which is here. So it will supply 40 and 50 to the method, and the method will find the average and it will save it into average one. For the next invocation or for next call, it is calling again getAverage, but this time it is calling getAverage with the three double input parameters. And when the compiler tries to find which method should call, it will check for the signature for each of these definitions, and it will find that this is the appropriate method that should be called. So it will supply 1, 2, 3 as input parameters, and the method will find the average and return it to the main program and save it into average 2. Now for average 3, the input parameters are characters. So therefore, the compiler will try to find the appropriate method by matching the parameters. And since the first two definitions don't have input parameters character, it will find that the third method has two input characters, therefore it will match it and will call it, and the return value will save it into average 3. Look at the definition for the last get average for two characters. In fact, what the method is doing, it is first converting the first character into integer, and it will convert it into ASCII code, and the second character will convert it into integer, which will be also ASCII code. It will add them together. The answer is integer divided by 2. It will get an integer. The result as an ASCII code will be converted to character, and this character will be retained as a return value for the method and will be saved into average 3 as character. So the output for the first average, it will be 45, the second average is 2, and the third average will be a letter, which is B. When there is overloaded method, the compiler, as we mentioned, distinguishes between multiple definitions by their signatures, by the number of parameters and their data types. Now, if there is no exact matching for the calling method, then the next step, the compiler tries to do type conversion if conversion is possible. For example, if we are considering the getAverage method in our previous example, remember that we defined it 3 times. In the first definition, the signature had 2 double input parameters. The second signature had 3 double input parameters. The third signature had 2 characters, 2 input characters. So now if we try to call getAverage, but the input parameters are all integers, we don't have a definition, we don't have a signature for the definition that all input parameters are integer. So there is no exact matching. So what the compiler will do, will try to do type conversion. Now, since integers can be converted into double, then what the compiler will do, it will convert the input parameters from integer to double and will call the overloaded method. Generally speaking, the compiler attempts to overload before it does type conversion. In other words, if it could not find an exact matching for the input parameters in any of the method signatures, then the next step, it will try to do type conversion. Although type conversion is allowed, but be careful when you write a program and never depend on type conversion unless you are sure that the type conversion will not give you logical errors or bugs in your program. Consider the following example for the petty class. Remember, in our previous example on petty class, we defined 3 data members in this class. The first was the name of the pet as a string. The second was the weight of the pet as double, and the third was the age of the pet as integer. Also, we defined multiple constructors in this class. One of these constructors was used to initialize the object if the weight of the pet was given as input parameter, as indicated in this example. Now, in this example, we are creating an object from the petty class when only the weight was provided as input parameter, and the weight as indicated in this constructor is given in double. In addition to this constructor, also we defined another constructor that was used to initialize the object if only the age of the pet was given as an input parameter. And the definition for that constructor is similar to this constructor, except that the input parameter was defined as integer because the age of the pet was defined as integer. In other words, if the input parameter to the constructor is double, then the compiler will call the constructor that creates a pet object with the input parameter as the weight, and if the input parameter is integer, then the compiler will call the constructor that creates a pet object with the input parameter as the age. So if the input parameter is double, then this input parameter represents the weight of the pet. And if the input parameter is integer, then this input parameter represents the age of the pet. Suppose by mistake, however, we forget the decimal point and the 0 in the input parameter. So instead of writing 750.0, we have written 750. Then what will happen? Then instead of creating a pet object whose weight is 750, we create one whose age is 750. The reason is that the argument 750 is of type integer. Therefore, it matches the constructor that has one parameter of type integer, and this constructor was defined to create a pet where the input parameter is the age. And that doesn't make sense that we have a pet whose age is 750. So this error happened because of the type conversion, because we forgot the decimal point. So instead of creating a pet object who has the weight as the input parameter 750 pounds, it is going to call the constructor that will create a pet object whose input parameter is the age of the pet, which is 750 years old. In conclusion, sometimes problems might happen if type conversion is applied on overloaded methods. Another problem might occur on overloading is that sometimes when we invoke or call an overloaded method, the compiler is confused which method to call. Consider the following example. Suppose the overloaded method or problem method has two different signatures. The first definition is that the input parameter, the first is double, the second is integer, and the second definition, the first parameter is integer and the second parameter is double. Now suppose we are calling the method by supplying two integer parameters. Then the compiler will assume that this is an ambiguous invocation of the method. Why it is ambiguous? Notice the following. We have two signatures for the method. When it tries to match the parameters, it will find that none of these signatures can match these two input parameters. However, if it tries to do type conversion, there are two choices or two options. If it converts the first parameter into double, then it is referring to the first definition. And if it tries to type convert the second parameter, then it refers to the second definition. So the compiler is confusing which method to call. Is it going to call the first method, assuming that the first parameter should be converted to double, or call the second method, assuming that the second parameter is converted into double? And this decision has to be done by the programmer, not by the compiler. Therefore, the compiler will be confused, and therefore it will assume that this invocation is ambiguous and therefore will generate a syntax error.